Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we are going to be talking about AirShaper. Specifically, we're going to be looking at flow simulation on a full car. Now, when we did our series a little while ago on scanning, part design for 3D printing, and then a little bit of flow sim on that intake duct for my Starion, I had some requests to do full car simulation. Now, with the free version of SimFlow, there are a lot of restrictions in terms of the number of cells that you have in terms of calculating the airflow. And so playing around with that, I wasn't really sure it was going to be the right choice for that. But thankfully, AirShaper reached out and asked if I wanted to try this, completely unprompted, but asked if I wanted to give their program a shot, see what I thought of it, and if I wanted to make a video. So there were no strings attached. I'm not an affiliate. They're not paying me to do this video, but I was given some credits to try out the software. And so in this video, what we're going to do is we're going to talk about the process. We're going to take a look at the car that I designed in Fusion, of course, and we're going to go through how to set up an AirShaper. We'll talk about the plans that they offer, and we'll review some of the changes I made and how I used flow simulation to drive the design. Now, there are some cool aspects of AirShaper. For example, they have a version that you can use where it will actually manipulate the design for you to improve the aerodynamics. It's going to be creating a mesh file, and the output is going to be a mesh file, so then you could use that to make tweaks or changes to your design. We're not going to be going down that. We're going to look basically at the basic simulation, which is 1 credit to solve. And then we're going to be looking at sort of a medium resolution simulation, which will be 10 credits to solve. And I'll talk about all that in just a little bit. Another thing that you might notice is that my face is on the video now. And so it's something I'm trying out. And essentially with all of the AI content that's coming out and the probability that my voice and likeness and things are going to start to show up in other videos, even though I haven't given permission for that to happen. I just thought I'd start, using my webcam recording, and that way it'll be something that will at least remind you that I'm a real human and not some computer. All right, so first let's start by talking about the car. All right, so I started this, basically I started a different design and completely scrapped it. And this car is basically taken inspiration from a lot of different vehicles, and it wasn't intentional. I did have a canvas in here of a Porsche GT3 RS. That is one of my favorite looking cars. I'm not about to spend $250,000 on a car, but I kind of threw that in there as a reference. But as you can see, I didn't use it at all. This is completely different shape, but I did, at least start out with that. So this car has a couple of things. It has a front end that is very reminiscent of a first-gen Camaro. I did have a 68 for a while, or an early or late 60s, early 70s Dodge Charger. There are elements from the Hyundai N74 concept, which was, kind of a second take. Hyundai originally licensed the DeLorean design and never used it, and then it turned into the DMC DeLorean. But the N74 was a hydrogen concept car they did not too long ago, and I really like the look of it. I'm a fan of 80s vehicles and sort of boxy vehicles, so again, took inspiration from that. Did sort of a cowl hood on the front. There were a couple versions of this car that I did, and if I take a look in here, so I did some more Coke bottle shaped designs and things like that. I didn't end up using them, obviously, so we kind of went with this design here. But the roof line and sort of windshield, very reminiscent of the Starion, early 280Z, Supra, things like that, AE86. So again, kind of boxy, not great for aerodynamics. Rear quarters, again, kind of reminiscent of different cars. They have a little bit of, again, that Dodge Charger feel from the top down. The back end is very much, like either Porsche, Aston Martin kind of style. And again, it's just kind of a mashup of a bunch of different cars just to get something that was that unique, kind of that 80s hard edge flavor, but soften the lines up. And again, it was just an idea. This is a solid, so if we are to basically do a section of this thing, it is a solid body. And this isn't going to work very well because the other analysis is on. But basically, this thing is a solid body. And the reason for this is because when we're trying to do a concept car design, an analysis, there are a lot of decisions that we need to make along the way. Now, in most cases, when we're doing just concept designs, we don't care how it performs in reality if we're just trying to come up with a unique concept. And I've done a couple concept cars that were probably worse than just a box van. But in this case, the idea was to create something, use simulation to dictate or drive some additions of aero elements or air handling, ducting, and things like that. So there's no openings on the grill, there's no openings on the front, and using simulation was going to help us determine what we needed to do. So from that, ran some simulation, came up with a second version of this. So basically, the main change here is some airflow that was going from the bumper and coming out the side based on the simulation results. We'll talk about those in a minute. There is an airflow path that comes up in the cowl hood and dumps out on the windscreen. And these paths here come out of the side. And the intention there was really to disturb or disrupt the air that was stuck there. And I also did put sort of this little channel under the bottom. Didn't really work out as I planned. And if we rotate this thing around, I did also try to do some ducting that went in from the wheel well. Didn't really have any impact on the design. But again, it was just kind of trying stuff and seeing how it stuck. With results from that, went on to the next concept, which basically I did some smoothing out of how it entered the grill up front. I divided this at the back. So basically, when the air was coming out here, I split some of it up and I split some of it down. I ended up changing the shape of this and moving it slightly. And then I also added some ducts. Now these go to the brake area. So in reality, it's not really doing much for us in terms of the flow simulation because the wheel wells are just basic shapes, but it does give the air somewhere to go. I also did change the bottom, doing a little bit more in terms of trying to handle the direction of the arrow. And then the last concept, the main change to this one here was the addition of a spoiler. And it's just like a little duckbill spoiler, not the most efficient thing. I really just didn't want to put a big spoiler on it and break up the look or the shape that I was going for. So it's kind of where everything evolved in terms of the concepts. Now, how do we arrive here? Well, we got here by creating some simulation studies in AirShaper. So what I want to do next is I want to go through the process of setting it up, and then we'll go and we'll look at some of the 3D elements that we can look at in here. We'll also go through some of the reports that we get. So the way that we go through this is there are a couple of different options when you have AirShaper. And again, this isn't a sales pitch by any means. As I said, I'm not an affiliate. There is no benefit at all if you buy, but I just do want to highlight that of all the different CFD softwares I've used over the years, and I'm by no means a CFD expert, I don't do it that much, but this has been by far the easiest that I have ever used, ever set up. It's basically does everything for you. But there are a couple of options. Again, the Discovery one, which gives you 25 credits. Again, the solves do cost credits, similar to how things work in Fusion, where you use the tokens or what used to be called cloud credits. So if you want to solve a simulation study in Fusion or generative design study or whatever, you use those credits. So this gives us basically access to basic accuracy simulation. So we're going to look at some results that are basic accuracy. And then we'll talk about the sort of mid-level accuracy. And essentially what happens when you think about simulation in general is taking the entire environment around your design and breaking it up into these little cubes. And those little cubes are going to represent the resolution that you have. So if you convert a design to a mesh, for example, you take that solid design and you convert it to a certain number of triangles. Well, when you're meshing a simulation, you create these elements and it calculates what happens in those little boxes. So when we're talking about things like accuracy of the simulation, the resolution, that is important because the more detailed your model is, the higher resolution that you really need to do to get accurate results. So I have a couple examples that we're going to talk about where I did a basic and then sort of the mid-level analysis. So it's looking at, I think it's 1,000 and 10,000 cells, or think about it as like an element. And we can see the difference in the results between those. So just to give you an idea of sort of how the accuracy is. So once again, a discovery, about $1,000 a year, 990 euros, and you get 25 credits. The professional one is about 3,000. You get 100 credits, and there's a custom one. And there are a lot of cool options that you get. There is, again, access to people that can help you with this. So you get some additional features like the option for it to go through and adjust your shape. There's also design advice that you get. And there are tons of tutorials, really high-level tutorials on nearly everything. So I would definitely suggest, if you're interested in AirShaper, to check out their tutorials. I'll leave a link to AirShaper in the description, but pretty easy to find AirShaper. But again, I'm not an affiliate. I'm not getting paid for you to buy this or anything. But if you're interested and want to take a look at the tutorials and things like that, then that information will be there for you. All right, so to get started, you basically need to give it a name. I'm just going to call this one test because I'm not going to save it. But you need to give it a name, and then you need to bring in a file. Now, I have played around with a couple different files, from step imports to STLs and OBJs, and there are some cool things. So if you dig into AirShaper, it will work on mesh data. So in most cases, when you're dealing with simulation software, it will want you to bring in solid data, a BREP or a NURB surface. Then it can translate it to its own mesh. Well, this actually works on mesh directly, and all the elements don't need to be connected either. So in most cases, you will need that watertight volume. Where AirShaper differs is it actually gives you a lot of flexibility. So I could have done something like scanned a car and done a simulation. I just thought it would be cooler and easier for me to do a concept car rather than to spend the time to do a complete, fully detailed scan of an entire car. You don't necessarily need to seal everything off, but you'll get better results if you do, because air will travel into certain areas and so on. All right, so we got it named. Browse is the next step. So what I have here is step files, and I've got some mesh files. What I'm going to do is just select a mesh of the last version. I'm going to say open. And then at the bottom, you've got your simulation goals. So we're going to run a simulation to do external aerodynamics. So again, it starts from 1 credit. 1, 10 are going to be the basic, and then that sort of mid-level option. There's this optimization option, which again will allow it to tweak and adjust the shape for you to get better. And there's a beta version of internal flow. For our purposes, again, external flow is what we're doing. All right, so the next step, and again, if you've ever tried to use CFD before, or if you followed along with our CFD video using SimFlow, you'll know how minimal these settings are and how easy this is to set up. Again, I've never seen any other CFD software that was this easy to set up. So the first thing that we need to do is pick the simulation type. So since we're doing a car, it'll be on the ground. If you're doing an aircraft, airplane, or a drone or something like that, obviously that would be above the ground. Because we want the car to be driving along, we're going to set it to moving. And obviously we're going to be doing this in air, but you do have a water option again. So if you're doing like a submersible, or again, off the ground for things like airplanes, you can do that. The velocity in our case, I've been setting everything at 100 miles per hour. Probably should have set it lower, but just for consistency's sake, I'm going to set it at 100 miles per hour. The units, of course, you need to pick depending on the export. So in Fusion, you have to just pay attention, because sometimes even if you have a design in inches, for example, and you export a step file, it'll likely bring it in millimeters, for example. In this case, exporting something like an STL, then it should retain the units that we had. So the file I have was designed in inches, and really the only definition that was using dimensions was the wheelbase. So it doesn't really matter. If you do happen to pick the wrong units, you can always change it. You can always change the scale here too. So the next thing that we see here is a preview on the screen, and obviously the car is going sideways, so we need to rotate it. Now, the rotation can be positive or negative values, so in this case, minus 90 degrees. it'll rotate it so that the front is pointing in the correct direction. Now this is going to be, again, it's going to be based on the coordinate system. So if you're doing this in Fusion or a program where front is in the Y direction, then you just probably need to flip it around. Now, one of the initial mistakes that I kept making was I kept clicking the set button. You do not want to click the set button because that actually changes the rotation reference in the CAD file. And what ends up happening is it'll try to calculate the simulation with the vehicle rotated sideways. We obviously don't want that. The other thing that we need to do is click on the wheels. Now, you can click on wheels and you can set them yourself, but if you just let it crank away, it'll automatically identify those wheels just based on the basic geometry. Now, I don't have fully detailed wheels here. You certainly could. You could add brake rotors and calipers and all kinds of other stuff. But I just have independent solid bodies. They are tilted at different angles to represent things like camber, but they are just, essentially cylinders. Once that's done, we're going to say done. So now we've got all four wheels rotating, and you can see here that we've got the airflow going over the vehicle. It's in the correct direction. The units here on the side, the wheelbase is like 96, 97 inches. So that scale basically for that red bar, that looks to be about correct. And you can see here the dimensions at the bottom. So I think everything looks okay. We're going to hit next. And then from here, we just need to pick our basic options. So once again, basic 1 million cells. It says it runtime is 30 minutes to 4 hours. Every one that I've run has taken 30 minutes, almost to the minute. And then the regular is 10 million cells, and then advanced is 50 to 100 million cells. So what I did for this project was basically ran each iteration at basic, so a lower resolution, got some feedback, made some design changes, and then ran the next version again. At the end, I reran the first version, the initial car with no ducting on it, at regular accuracy, and then I ran the last version at regular accuracy. So this gave me sort of the baseline to see the difference in the accuracy for the first version with it, with no ducting, and then the version that I ultimately ended up with, which is these projects are never over. So I could always continue to make changes, but that's kind of what I did, was the basic accuracy and then regular for the finals. There's also a design advice option. The credits are based on which one you select. So if you use regular, that's going to be 10 credits for design advice. If you use basic, it's 1 credit. And you can do things like tell it that you want to reduce the amount of lift or increase lift. Obviously this isn't just for cars. So if you're looking at an airplane, for example, and a wing design or something like that, you may want to increase lift or reduce drag. These are all different options. But basically you pick which one you want, use the design advice option here, and then you let it crank. Excuse me, let me go and just get a little tea. Normally when I don't have my face, normally when I don't have my face on the camera, I don't have to worry about that. I can just pause it. And that's basically it. You start the simulation and you let it run. Again, I'm not going to do this. It's just going to save it as a test draft. It doesn't use any credits to set it up. But again, that's probably the easiest setup that I've ever seen on any simulation software, not just CFD, but just any. All right, so let's go ahead and just take a look at the 3D information that we get, and then we'll take a look at some reports. All right, so on the left-hand side, we've got a couple categories for visuals. We've got a category for forces. We've got downloads. So this is a PDF report, simulation data, the model. Now, remember, it's converting it to a mesh. Even if we actually upload a mesh, what will happen is it'll create a version of the file as its own mesh. And this helps because it does things like separates parts for you. It does things like it'll create in this case, the basic accuracy will create a lower resolution mesh than we uploaded. So if you want to download that model, you can. If you're not using the version of the simulation where it modifies the design for you, there's probably not a good reason to download it, but you can. There's information here which talks a little bit about the convergence and the scale and the basic settings, and then you can share the entire thing. So let's take a look at some visuals. So the first thing we have is pressure clouds. So these 3D pressure clouds are basically looking at areas where drag is happening. All right, so this is where the air is essentially sticking to the model. It's not flowing over it like we would want. So there's a lot of drag that's happening on the nose, which makes sense because we've got no openings for the air to go. It's basically just this brick wall that's ramming into the air. You can see here because the tires are sticking out so much, and this is an aesthetic thing, that there's a lot of this sort of area where the air is sticking to the front of the tire. Tires in general are going to have this anyways. You can see right here where a mirror would be. I didn't model any mirrors, but that would have an impact. You can see that it's sticking to the side of the car for quite a while and underneath. So at the leading edge of that air dam, it's sticking there, and you can see that it's coming off the rear wheels and it's sticking as well. Now there is a little pocket in the middle, which means that we are getting some fresh air under the vehicle that's breaking it up. But for the most part, you can see that it's sticking to the back of the car. The next thing that we have is surface pressure. Now the surface pressure is going to be high in red areas and low in those blue areas. So just like we saw the air kind of sticking to the vehicle, we're also seeing that on the nose of the vehicle. And again, there's nowhere for the air to go. So it's basically, if we look at it from the side, it's hitting the front and it's rolling over and then attaching back to the car. You can see at the front edge of the tire, kind of the same thing's happening. And then you can kind of go around the vehicle and just identify those areas. Surface friction. Now this is kind of a cool plot because this gives us the flow lines. So as we're looking at it, again, the air is hitting the front, so that green area is going to be where we have attached flow. So basically the flow is sticking to the car. The blue area is where it's, I guess it would be lower friction. So it's where the air has separated from the car. So again, it hits the front, kind of jumps over, hits there. And then there is the kind of, intake area, or the scoop that's going to happen here, the cowl on the hood. And there's that spot right at the front of it that's happening. And then on the sides of it, we've got this air sticking. And then at the base of the windshield, we see that as well. And so we've got those, again, the green areas where it's kind of sticking and flowing along the body, the blue areas where it's not, it's kind of bumped away. And then we've got these other areas, these red areas where it's really rolling around those corners. So as I look at this could help me indicate changes that need to be made for, say, the front end here. Also, if I wanted to round off the A-pillar area a bit more. Now, obviously, this is a low detailed model. I mean, it has a lot of detail, but it doesn't have things like trim for a windscreen or windows or any of that stuff cut in. It's basically a starting point. Next, we've got vertical streamlines. So this is basically a cut plot where we're looking at what's happening right in the center of the vehicle. Now, as we look at this, a couple of interesting points here. When it hits the front, you can see it's jumping up before it's coming back to hit the hood. So we've got that area where we had that blue low pressure, the pressure cloud identified that. And then when we look at that vertical streamline, we're seeing the same thing. And then at the top, it's pretty much something we can't get around, especially with the shape of this car. We're going to have those areas on the top of the car. And then because there's no spoiler, you can see the air is just kind of falling down, and where it's coming underneath the vehicle, it's rolling up. You'll notice there's some red underneath the front. And again, it's kind of hitting the front of that lower portion of the air dam, and it's forcing it down away, and then it doesn't become green again until right here, which means that's the point where it kind of sticks back to the car. And we get the same plot with horizontal. So basically it releases a stream of these, these flow lines, and we can kind of see what happens as it goes over the vehicle and what happens behind it. Then there's a noise plot. So the noise is looking at areas that are going to essentially be creating noise, like wind buffeting. And I think that we've probably all been in vehicles that are quite a bit noisier than others. And we can see the areas that, we had in the 3D pressure cloud, like on the leading edge of the hood. Those areas where the air is not sticking to the vehicle, it's kind of hopping away. Those are areas that are going to start to be, somewhat noisy. And we can also see some of these that are going up around the A-pillar and right at the base of the windshield. Some vehicles, if you drive, you can kind of see windshield wipers flapping around if they're not very aerodynamic. Most cars now, and for the past 20, 30 years, have tucked the wipers down pretty far into the cowl vent, but those are kinds of things that you can identify and see from the software. And again, there's a forces section to give you information about things like the drag coefficient. So this is 0.341. I think it's pretty good for the shape that we have here. Now, obviously, if you look at more aerodynamic vehicles, you're getting below like around 0.2, for example, especially cars that are trying to be super efficient. They want to slip through the air quite a bit better. Cars that are generally more performance cars will probably be in this area somewhere. I don't have a range of them, but that's not really that bad. That's roughly close to what the wide body version of the Starion is. So it's a good starting point at the very least. And then in the download section, we can take a look at PDF reports. So I'm going to go back and take a look at version 1 high res, and we'll look at these reports side by side as well. So version 1 high res, it's the same exact model, but there are going to be some nuanced differences because we now have more cells. We're getting a more accurate result. The mesh resolution is quite a bit higher on the vehicle, and also the number of cells that build the domain that we're looking in is also quite a bit higher. So we're getting a better outcome or better result or more accurate result. So as we look at surface pressure and surface friction, these are mostly the same between the basic and the medium accuracy, but we are certainly getting more details in some areas. So we're getting more blue on the rear window and on the quarter and that sort of C-pillar area. These are areas that weren't really identified as having that detached flow in the lower resin. And you can kind of see up here as well. Now, one of the big things as well is if we go to the information, actually, let's go to forces. You can see the drag coefficient is lower. It's 0.312 instead of 0.34. So with the higher resolution, we're getting more accurate numbers. Now, one concerning thing here is on the front, we've got a negative number for lift, which means we're actually getting some downforce. On the rear, we have a positive number, which means the rear is lifting up, which we don't have a spoiler on it, so probably what we would expect to see. But again, these are kind of numbers that we use to determine what we want to do going forward. We can use all the visual plots to determine where we want to make design decisions and design changes. So looking at these results, the design decisions come in a couple of different areas. So if we look at, let's say, the vertical streamlines, and I'll rotate this around a little bit. So knowing that we've got this area right at the leading edge of the hood, you can also see that when I designed this, there's a little bit of a dip right there. So this tells me that the nose itself needs to dip down a bit more. And also, obviously, we need to deal with the air going somewhere. So the second version of this was really to take a look at getting the air to go somewhere. And once we got the air to go somewhere, some of these pressure clouds began to change. So the second version of this allowed us to take air through the front, the big grill opening, and have it come out basically at the windscreen on that cowl. And then some of the other areas, so right there where the headlights would be, I dumped it out here to try to get these sort of 3D pressure clouds, those areas where we got that drag, to separate from the vehicle. The ones on the lower part of the air dam are popping out here. And again, the idea was to get those to go away. And other than that, there wasn't really that many other changes. I tried to handle the air underneath the car a little bit better, and it actually got worse. It didn't really do much for me. And you can see we still got those sort of pressure clouds up front. So that second version gave me a bit more information. I needed to do better up front. I needed to smooth the transition of the air coming in. I needed to do a better job getting that nose to come down. And then I also needed to maybe rethink some of the different areas where I was handling the air. So the third version basically smoothed out the inlets, and I added a second pair, and these are actually brake ducts, so they go behind the wheel. And the idea here was to lower the center front nose, get it down a little bit better so that it was a smoother transition to go up onto the hood. That seemed to work. I added a divider in this outlet here, trying to push some of the air down, and it seemed to work and help separate this from the car a bit. So you can see here it's pushing it away. And in the rear, you can see there's a hole in the center from trying to basically get the air to flow in a certain direction and break that pocket up. So if we look at surface friction, you can see the lines, and you can see how it's coming down, kind of going out toward the side of the vehicle and coming back. So carrying these a bit further forward or doing some more to try to direct where that air is going to go could help. And also maybe sweeping them further up the back to give it a little bit more direction would help as well. But this is all good information. And again, these were all at that sort of low res. And it wasn't until the fourth version where I went to the regular resolution. So basically going from those 1 million cells up to 10 million. And the main design difference here was, again, the addition of that spoiler. And the addition of the spoiler was really to try and get those lift coefficients to either be close to zero or to actually get some downforce. So the change of the spoiler, as well as going to that higher resolution, allowed me to see that the front is now pretty much even. We could do a bit more aero on the front, but the rear has now got a little bit of downforce. And again, it's mainly attributed to having that spoiler there. Now, there are some, I don't want to say negatives, but there are some things that happened based on the spoiler. Now, some of the things we see, like again, that sort of pressure cloud at the top of the rear window, that really showed up as a result of going to that 10,000 cell medium resolution or medium accuracy. So it wasn't really a result of the geometry. But if we take a look at things like surface friction and surface pressure, what we'll notice here is that we've got a lot of this low pressure area. And again, remember, this is where we essentially have this pocket, and it's what we would expect to see because the spoiler is disrupting the air. So that's actually allowing it to push the air over a bit. But again, the air handling on this vehicle still could use a lot of work. But this little addition of that lip took me from having lift on the rear to actually having a bit of downforce. So from here, the next couple of steps would be to do a few more additions, probably get better at getting the airflow, maybe instead of doing that lip, putting a wing on it. But I really just didn't want to do that because this was a visual exercise, really more for me. I wanted the look than to worry so much about the performance of it at 100 miles an hour. But it was a good exercise and a good example to how we can take a basic concept that's a solid body and use the simulation to be able to identify these changes. So what we're going to do now is I'm going to take a look at a couple of the reports that come out of this. So we've got, these say high res, but it's the regular accuracy, which is the medium. And so basically what we have on the left is the basic accuracy, which was that 1 credit, and the one on the right is the 10 credits. And what we're going to do is we're going to go through the reports, and these are the reports that get generated automatically. So I didn't have to pick any details or create any slices or do any of the other stuff that we have to do with any general CFD software. And in most cases, what you end up having to do is create the slice plots and identify the information that you want to pull out and then generate those reports. So again, I could not say that this was the easiest CFD software I've ever used. They made it so easy for you to set up and use. All right, so the views are going to look mostly the same. This is actually a mesh view. So the mesh on the left is going to be lower resolution than the one on the right. Because there's no internal ducting, it really isn't going to make that much of a difference in the view. Like we're not seeing a large difference, but you get these rendered views. Now, one area you do see it is kind of in the wheels, where the wheel wells here, they're pretty tight on this first version. The higher resolution did keep the gap a bit better, but in version 3 and 4, I did open the wheel wells up. All right, so first we've got a performance analysis. So we get a little bit more information than we do just taking a look at the 3D images. All the information is there and available, but it puts it in this report form, which is really nice. So the first thing that we're looking at is going to be the forces. And for this, the pressure, really what I'm looking at is going to be the force in Z, so in, again, our vertical, and it gives it to us in the wind tunnel coordinate system, which is at the center of mass or the center of the vehicle, and then wherever your original coordinate system was. For this model, mine was actually in the same location, but it was on the ground, so it's basically Z is lower. And so you can see there is a difference in things like the pressure based on the coordinate system. Now, as we go down, we also get a moment. So what we're looking at here is, let's say, the moment about Y, again, from that sort of middle point of the vehicle. It's negative, and so that's going to dictate it's going forward, and positive would go the other direction based on that coordinate system. And then as we go down, there's a convergence graph. It basically told you, how many iterations it went through until it arrived at its conclusion. And then we get this little graph which shows you the coefficient of drag. So again, the basic simulation, 1 million cells, and the medium one, which was 10, you can see there's a difference. Same exact model, same exact setup, and we're going from 0.341 to 0.312. So as we increase the number of cells, we're going to get more accurate with the results. It also gives you some information about the required power, again, at the speed that you set for the results that we have. And each of these has a little paragraph that you can read on it as well. Next, we've got the aerodynamic coefficients. So it gives us things like the drag as the number here, but it also gives that lift coefficient. And you can see here it's negative in the front, which means we have a little bit of downforce, which makes sense because the nose is slightly angled down and there's nowhere for the wind to go. So it is pushing down on the nose a bit. And then we've got that rear lift, which again, the number drops slightly with the higher resolution, but it's still lifting on the rear, which we don't want to see. Now I'm going to scroll down through each of these. We've got 3D pressure cloud. Again, we saw these in 3D, and there's not really any additional information here, but we do get these sort of higher resolution rendered images, which are kind of nice. So you get the side view, the front view, the top view, the ISO, and they do the same thing for the others. So we got surface pressure. I'll just zoom down here. So again, you can see left and right, really not a drastic difference. Again, you can see that there is a little bit more of that teal color, and the blue is going a bit further onto the hood in the higher resolution version of this. And you can kind of see the same thing. We're getting less of the pixelated colors as we add more resolution, which makes sense. So that's what you would expect to see. But again, for a first attempt, this is a great first start to kind of see if you're in the right ballpark. I'm going to go down. I'm going to scroll down a little bit. And again, we're just going to go left and right. You can kind of see higher resolution on the right. Gives us more information about what's really going on in the front of that hood, whereas the lower resolution just didn't have the number of sort of those cubes, those boxes, to capture that data. Now, as we look at things like top view or side view, they're not going to look too different. You can see that the blue that's right here, again, where the rear view mirror would be, you can kind of see they're very similar, just a slightly different size. But this also tells me this would be helpful for me to design and develop what a rear view mirror would look like if I need to adjust where the air is going, or maybe use it to deflect or direct air somewhere. And then next section, we've got flow analysis. Again, more information in the reports, and then it gives us those cut plots. So we've got the vertical one. I'm just going to scroll down to the side view. We'll do the same thing over here. Very similar. Again, there is not much difference left to right. You can see on the right, we've got this lower trace that was coming under the car and ends up shooting up a bit. And here it stays flat. And as we go down, you can kind of see that horizontal one. Again, very similar results. I don't expect to see too much of a difference here. One thing to keep in mind is what we're seeing here is a fairly small section of the domain. Typically, when you're doing a CFD like this, you have the airflow starting pretty far in front of the vehicle, and then you have the boundaries well above and beside the vehicle. The ground plane will be the sort of ground boundary, and then you'll want it to go pretty far off the back of the vehicle. And that way, you know that your boundary isn't influencing the flow. And then we get some 2D sections. Now, these are pretty nice to see. You can kind of tell what's going on with the air coming off the back of the vehicle. As we get to the higher resolution, we get a bit more information as to what's going on back there. As we look at the side, remember this has no ducting in it, so you can really see where it's sticking to the hood there, right at that nose section. You can kind of see what's happening to the air as it falls off the back. We also, actually, let's go back to that. We also see there's red underneath the front. Again, that's the air hitting, going down. Again, there's not very much room between the bottom of the car and the ground, so it's kind of jumping away from the car and then sticking back to it. And then we've got the same thing with 2D cut planes for pressure plots. So this is going to really help us understand the high pressure in the front of the car is great to get air into stuff. So whether it's going into an air box or going to cooling, oil coolers, radiators, things like that, you can really get a good sense of where that pressure is building up. And again, this kind of V front was based on the Envision concept. That's kind of how the front looks on it, and I thought it looked cool. And then the noise analysis here. So one thing that's interesting about the noise analysis here, again, it's really looking at what kind of noise is being generated from what the air is doing. And it comes in these 3 different colors. You can see in the higher resolution, it is really showing a lot more going on than it does in that lower resolution. And this is going to tell us that the front of this car is generating a lot of wind noise right there at the nose. The rest of the stuff back here is probably pretty normal. There's not a whole lot going on the wheels, but the front nose of that car definitely needs some work. So next, I'm going to take a look at a couple more reports. So what we have now, I'm going to skip version 2 because we're basically just looking through the same stuff. But what we're going to look at is version 3 iteration, and then version 4, which I'm calling the final for this video. So version 3, basic accuracy, again, that lowest, that 1 credit 1. Version 4, I ran at a higher accuracy just because I wanted to get more information out of it. And so as we go down, I'm just going to jump ahead to, let's skip through the views. We'll go to the side view just so we can see the difference. So mainly the same. Again, the biggest difference that happened between version 3 and version 4 was the addition of the spoiler and the higher resolution setting. So I was happy with what I got out of version 3. I just knew I still needed to add a little bit of downforce. You will note that from the original version to now, I did open the wheel wells up a little bit to give some space around the tire. Probably need to do more, but again, it's just a concept. So I'm going to go down to the first wind tunnel coordinate system, pressure and friction. So one thing you'll notice here on the left, the one without the spoiler and the lower res, that force in the Z direction, 605 newtons. With the spoiler, minus 120. So the force is pointing down now instead of up. And then again, we've got information about the moments. So as we look at the moments here, we had the moment about Y was minus 513, and it's now minus 24. So again, in the original one, we had lift in the rear, and now because we do actually have some downforce, it's got much less of a moment that's happening about Y. Now the coordinate system again is here, so Y would be the car pitching forward or backward, and X would be rolling side to side, and then if it's F, it would be twisting, but that really shouldn't be happening too much. You can see moment about Z is pretty low. All right, so as we go down, again, 0.34 was the drag coefficient on the higher res with the spoiler, 0.309. So it's getting better. It's getting better at the higher resolution, as well as, again, adding additional aero. So as we go down here, again, here's the important thing. So that coefficient of drag dropped, but the big thing here is that the total lift coefficient is negative. And on the front, it's close to 0, but on the rear, it's negative. And again, they're pretty well balanced, so pretty small. And so what I would say here is what I would continue to do is try to make it balanced, probably add some more aero to the front, maybe change the spoiler in the rear a bit. Right now, having it fairly balanced, not lifting the front or not lifting the rear, I think that's a good balanced result. Not a high performance car by any means, but it is better than having it lift the front or lift the rear. All right, and then as we're taking a look at the pressure clouds, the front pressure clouds here on the version without the spoiler and with the spoiler shouldn't affect anything because it's at the rear of the car. So really what we're seeing here, the difference is going to be just in the resolution. So going from that basic to that sort of medium. And as we look, let's go to a side view. As we look here, essentially what it seems like is the air handling to try to disrupt this seems to be working. Right, again, there is some brake ducting that's happening behind the wheel, not really going to do much for us because the wheel is just a cylinder right now. There's no way for the air to pass out of there. But these ducts, which basically are bringing fresh air from the front and trying to break this away from the car, those seem to be working. This one right here could come further forward on that rocker area, but the problem is having it sort of snake around the wheel well causes it to be at sort of a funky angle. So in order to get it to be pointing backwards and not out sideways, it really needs to kind of be in the middle of the car where it is. Now, in terms of surface pressure, we would expect to see a difference on the one with the spoiler. On the nose, we don't see much difference. There is a difference because of the resolution, but we don't really see any new areas of concern. You'll notice that I probably could have used more area for these, but you don't really need that much for brake ducting. So in reality, small ones on the side for the brakes, and then these could be for additional cooling. Those would be fine there. As we go to the top-down view, you could see it's starting to get a little yellow in this area where the spoiler is. That's what we would expect to see. Not really much difference on the side. Everything looks about the same. And then surface friction here. Again, the front should be largely the same, but one interesting thing here on the right with the higher resolution, we're not seeing any of those blue areas. Now, again, those blue areas, those are going to be those lower friction zones. So that's where the air has kind of separated or broken away from the car. And then the green is where it comes back and sticks to it. So what we see here is in the higher resolution, we don't really have as much of a problem as we do in the lower one. So as we're making these design decisions, if they're based solely on that basic accuracy, then we could potentially make some bad design decisions. So the big things like we need to get some air moving from the front sort of grate area, headlight area, that is okay for that basic resolution because we kind of already know that. But as we get into making maybe minor design changes, tweaking the shape of the nose a little bit, you probably want to be focusing a little bit more on that higher res. And again, as we look at this thing from the front, we can see the red and yellow is creeping a bit further up the quarter on this one here. We actually have a red all the way around the front here. And again, that's likely because of the size of the geometry at the nose of the car. The medium resolution probably just does, or the low resolution probably just doesn't have a small enough cell size to be able to capture that accurately. So there might be one cell there on the low one where there might be like 4 or 5 in that same area. So it gives us more accurate representation. But we can see here that the blue area where, again, we've got that sort of detaching section, and then green where we're ducting the air through, blue here, and then green. It turns to red on the inside because it's changing directions. But all that looks what we kind of would expect to see. Now from the top down, that light blue section right in the middle of the window, that's again an area where the air is trying to separate from. It hasn't completely separated, but it is trying to separate. What this tells me is I could potentially play around with doing a little bit of a lip spoiler at the top of the glass. And simply because we already have this red line here where the air has to wrap around that corner, we could potentially push it back a bit further, get rid of this lip spoiler, and put one a bit higher up in the airflow. And so that way we could maybe get the air to reattach a bit sooner and not have this big blue pocket. Again, these are all things that we could play around with and make design decisions on. Now on the low res versus high res on the side view, again, very similar in terms of the coloring and where things are happening. But one big difference here is you can see on the lower res that blue line is kind of coming down and going to basically that low spot on the wheel. But on the higher res, it's pretty much non-existent. There's not a whole lot going on there. And this basically happens because, again, the air is coming out of here from the front to there. And so as it comes out of that spot right there, what I could do is change the angle of that back edge to be more in line with the door. And that way it would try to stay attached. But basically it's rolling out of that little corner right there. All right, so next we've got the streamlines. Actually on the left, this is a version where I ran the design advice. And so in this case, I wanted to reduce the drag. So it shows me on the model areas where we would move inward and areas where we would move outward. So based on that low resolution, it tells us that we would probably bump these areas on the front of the vehicle, just the front nose of those quarter panels, bump those up, roll the nose, that front lip, roll that down, and then try to round off the A-pillar and the top where the windscreen hits. Now, you obviously can't get it perfect, but this is, what we're going to get out of the design advice here. So it gives us, some good input on where we might want to change certain elements of the design. Again, you have to think about the design aesthetics versus the performance and kind of what you want to do there. All right. So here's where we're going to start to see hopefully a big difference because of the addition of the spoiler. So the higher res from the left, probably not going to give us too much of a difference, but here on the left, we can see the air is following basically that rear window and dropping down to the ground. Whereas on the right, the higher res with the spoiler, again, right in that middle area there, let me try to zoom in on this a little bit more. Right in that middle area, we had all that blue, that sort of blue coloring, which means there's like a pocket of air sitting there. And so basically what's happening is the flow is going over that, and then it's kind of carrying and staying straight, and everything coming from underneath the car is kind of coming up to meet that. So I think that's a fairly good result for just adding that little spoiler. But once again, if we put a tiny lip at the top of the roof at the beginning of that glass, and then maybe had a spoiler a bit higher up, potentially, we could get some more downforce out of it. But I wouldn't do that without making changes to the front as well, because right now the car is fairly balanced aerodynamically. And then again, when we're looking at these horizontal plots, really what I'm looking at here is what's happening after the vehicle. So the lower res on the left, let me zoom this in, maybe we see it a bit better. The lower res on the left, what you see is that we've got these coming and converging pretty quickly after the car and then sort of bouncing back away. Whereas the one on the right, let's zoom that one in too. The one on the right, you can see the lines are actually appear to be going straight out of the vehicle. They're not bunching up right here in the middle, whereas they're kind of bunching up here. So just an interesting difference when looking at top down, just with and without that spoiler. Now, again, that was really the only change, plus the the resolution is going to make a change. And then we've got the 2D sections. Once again, because of the spoiler, we've got a lot more of that blue area on the back of it. One interesting thing, because the air without the spoiler is coming down, we actually have that separation right in the middle. Whereas with the spoiler, it creates that lower zone around the back, and it's not actually breaking through. So this tells me that I could do a bit more with the, with the arrow at the back of the car. We can see what's going on inside the ducts as well. So you can see that we've got that blue flow at the bottom here. So what this tells me is I likely want this to go straighter and then curve up more gradually. So I don't have that. Basically what's happening is the air is coming in and then it's sort of blocking that off right there. So I could do better in that section. And then when we look at the pressure, again, we got, high pressure at the entry of it, and then it's getting lower. It's still yellow right here, but it's getting lower as it goes back. Because this section plot is right through the middle of the vehicle, the only one that we're seeing this for is inside of that cowl hood, and we're not seeing the same sort of plot going through the other ducting, but there we go. And then the noise analysis. So one very interesting difference with the noise analysis with the spoiler is you can kind of see that without the spoiler, there's not really a whole lot going on the back in terms of generating that noise. There is a bit going on the side of the vehicle, likely from the air exiting here and hitting the air that's coming around the side. But with the spoiler, you'll notice that there is quite a bit of that buffeting wind noise that's probably generating something. Now, one thing that we need to keep in mind too is the numbers. So that light pink is 5.7. The middle one is 6.7 and then 7.7. So as we look at these colors, there is some of that red color around the front wheels and a little bit around those front corners. With the spoiler and the higher resolution, we're actually seeing some at the top of the windscreen on the roof. So that could potentially be really annoying. And we would want to address that as well. But it would be good to know if that was true higher res without the spoiler. I can't imagine the spoiler is really affecting this much. So this is probably just a difference in resolution. And that's the end of the report there. So just to kind of circle back into the 3D information here. So I think, just a takeaway of this is that the idea or the intent behind it is to take a concept, now in this case, a concept car, it could be an airplane, drone, boat, whatever, to take a concept and without spending dozens or hundreds of hours developing it, do some initial simulation to figure out if you're going the right direction, right? Now, if you're making something that is completely aesthetic and the performance doesn't matter nearly as much as the look of it, that's one thing. But if you're really driving toward something that has a performance aspect of it, whether it's aerodynamics or generating lift for a wing or whatever the case, then doing some initial concepts like this and then going in and doing some simulation to maybe make those design decisions, like where are we going to take the air? Where does the air need to go? Do we need to add little pieces like this to get air to go around the wheel? Or can we leave, the wheels exposed? So, adding these little pieces helped get rid of those pressure clouds right in front of the tires. In reality, a design change to bring the bumper out or the air dam out to cover the wheel would have been much more efficient, but it doesn't really fit with the look, the look that I was going for the front of this vehicle. And then just playing around and trying some different things. Now with AirShaper, again, it is a paid software and you do have to use credits in order to solve these, but doing those basic simulations. So if we go back to this draft, running the basic simulation with 1 million cells with that one credit, then getting some information, getting some information about those results, making design decisions, trying again for, basic simulation until you're happy that you're going the right direction. Then you can put in the time to do a bit more detail. Now, all said and done, I threw this concept together pretty quickly in just a couple hours. Did, obviously several simulations. I spent, probably 2 hours on the initial concept and then probably in total another 2 hours adding ducting and making design changes and things like that. Pretty much all of the design work was done with forms, everything from the ducting. So if we take a look at this right here, so all of the ducting was done as freeform bodies. The initial car obviously was done as a freeform body. The brake ducting were freeform. The splitters on the bottom, I did those as freeform. I did play around with a couple spoilers and did those as freeform and some other stuff that I scrapped completely. So it is a really quick way to play around with making these concept shapes without having to spend hours and hours and hours on traditional surfacing. Now, that doesn't mean that it could be the final solution, but it might get you in the right direction. So now, if you have any questions on AirShaper, I will do my best to answer those questions. If you have any questions on the design, I didn't want to turn this into a design video because really the focus was meant to be simulation. But if you have any questions on the design aspects or elements or anything like that, then please let me know that as well. And any questions in general, just leave them. And if you like seeing this kind of content, you want to see more with AirShaper, then please let me know that as well. And I'm more than happy to do some more videos with AirShaper. Again, not an affiliate, not associated with AirShaper, not going to get any benefit if you buy it or don't buy it, but I was pleasantly surprised with how easy it was to use. And in terms of CFD, it is actually quite less money than most other CFD programs will cost you as well. So not only is it cheaper, it's so much easier to use, and so far I've had great support. All my questions have been answered quickly. I've been able to, get design guidance and advice and all sorts of stuff, which is probably not the normal thing, but they do offer that as a service, as design advice and helping you with the aerodynamics. So I do strongly suggest you at least check out their videos, the tutorials, get an idea of what the software can do, because this is just, a basic, new user introduction to it, and then make a decision from there. But once again, any comments or questions, leave them on the video below. As always, thanks for watching. We'll see you in the next one.